start recording here. So today is our final kind of MP demo day, and I'm just really happy everybody, for the most part, is here. We had our expected order, but we'll kind of shuffle things for now. That's too bad. I'm looking forward to that. So we will start with group number 2 today. And in general, I know there's a lot of you standing around here. This microphone should be working so we can kind of pick up your comments on the recording here. It's always hard to give a presentation. It's not like you've been practicing this presentation, but try to have, a logical order to your presentation and know what people are going to talk about. So group number 2, you're on the hook for starting first, so why don't you all come on up for group number 2. Sure.
Who's going to talk about size slides? Who's going to talk size slides?
The size also not here.
Yeah.
That's fine. Group 1 can actually go if you don't mind waiting 2 minutes for Sai. Is Sai coming though? Because if he's not coming, that's a different issue.
No.
You have about 10 minutes to text him and scare him and say, Professor Zambrino's really mad. He's yelling about Sai not being here. And you didn't even notice I wasn't here. So group number 1, now you can get started.
Okay. I worked mostly on the depth and blending hardware and driver changes.
I did some MP3 bug, all the MP3 bug fixes, unnecessarily created unnecessary IPs, and then I worked on the fragment shader hardware.
I helped with the alpha test application, and I attempted the texture and full test application, which mostly worked except for alpha.
So bug fixes for MP3, one of the big ones was correctly flushing the DMEM and IMEM, but that wasn't the main issue that we were having why we weren't getting like triangles to show up. It was just because I forgot to set the next state after FML2 state, so it was like infinitely stuck in that state. So it took way too long than what it needed to be, but I figured it out. And then I wish I took pictures of my results, but you'll see that future slides that it does work.
Isn't it funny though that like that state machine's quote unquote rookie mistake, but with all the complexity of the design, it can just be hard to spot, right? And to know that.
For the longest time, I thought it was because I wasn't flushing things correctly. I tried a lot of different ways, but it wasn't. It was just the hardware. So.
Yeah. So for our second version of the render output, I put the state machine on the right, but it pretty much has 2 different paths for if depth is enabled and then if blending is enabled. I added a couple different registers to act as control for that, and then the blending factors and depth function. And then there's also a pathway where if neither is enabled, it'll just write whatever it gets in. And then for the blending, I kind of determined this was the general hardware circuit you need for 1 lane of the blending, so for RGBA. And so right now we have basically 4 in parallel. But I figured later on, if we're running low on resources, that would be something we could just do 1 lane at a time and reuse the same kind of hardware for that. So. Yeah, and then so for depth testing, kind of in addition to that state machine, I actually ended up adding a second cache to our render output for the depth buffer. I don't know if it was necessary or not, but I figured they were reading from different base addresses, so it might improve the performance a bit. I also created a depth clear buffer, and then did the clear depth value to set all the values of that buffer, and kind of did a similar format to what was already set up for the color buffer for depth clearing and everything.
Did everyone do a depth clear buffer? We'll get to it when you get there. Okay. Because I saw some results, but maybe they were just in progress where it looked like you were doing depth, but maybe there was garbage in the depth buffer. Not your group, but other teams. I thought that might create.
Yeah, we did end up having some issues where the clearing wasn't working right, and I had to add a wait for the DMA to be idle.
Yeah.
Otherwise, it would cut off the earlier request. And so that was an interesting bug from earlier. But these are some pictures. The two on the right are like it working for GLS and GLGrader. That picture with like the overlap is when I didn't have the DMA idle thing, so it was like cutting off the clear. And then the cube, we're still having this issue where like on the edges, I think I saw a lot of other groups had that problem too. The edges aren't like quite doing depth testing right, so I'm not exactly sure what's causing that. I think I was talking to Jeremy about it, and his was like that too. So one possible reason I thought is that we're not really clamping depth values like between 0 and 1. So there might be some negative ones from interpolation, but I don't really know how that would affect it. So we haven't done a lot of testing to fix that because I thought it was good enough and I wanted to move on to blending at that point. So.
Right, I agree with that. I don't know, but it could be, post model view projection transformation. I think the values, there shouldn't be clamping, we could check, but I think the values would, if anything, get smaller, not bigger after that transformation. Maybe they're too small, maybe they underflow or something like that, where you get really at the edges, you get really small differences, and they become ties in your depth.
Yeah.
Because if they're normalized, then that like Q16.16 doesn't make a lot of sense for representing.
Mm-hmm.
Maybe you'd want to do like 1.31 at some point or something like that.
Yeah, and then the blending, we have some other applications. Yeah, we were getting a lot of black triangles for a while because I was using one of the colors in like the 0 to 1 range, and it was supposed to be 0 to 255, so it was making everything black. But this, these layered triangles is kind of an interesting application that Maisie made. I don't know, do you want to talk about how it works?
Can, I guess. So I had different switches to switch between source color 1 and source alpha, and it gave like a different overlay effect. And then also I made it so the triangle on top could switch between colors, like you could change how much of each color based off keyboard. And then of course how opaque it is.
So it was kind of like that one just demo app I showed the class where it was like 4 strips and they were overlapped. The only issue I always have with alpha is when it looks blended, it looks like it's okay, but it's hard to know, is this the exact result? You have to go back to pencil and paper again to say, okay, for this source alpha, 1 minus source alpha, these 2 colors, here's what the value should be. It's hard to do that, I guess, and you have to kind of manually test. But if things look like they're blending, that's probably good enough for our purposes.
And when we read some of the documentation, it said like the in-between blending wasn't super strict as long as like the 1 and the 0 were set up correctly. So that's kind of what we went with.
For the fragment shader, I didn't realize you could just make another instance of the same vertex shader. So I tried like copying all the vertex shader files into a new IP and then handling all those things, which I just talked to other groups and they just copied and made another instance. I was like, okay, that's just a lot easier, and then changed the memory address. So that's what I ended up doing. Besides that, I just updated the drivers so that I added a program counter start address for when in the driver for the fragment shader, and then flushing the caches. I didn't have to do anything with the count, like the vertice count register, since it doesn't matter for the fragment shader. The fragment shader didn't really cause any glitches that I've seen, so because it's pretty straightforward. And then those are the test applications. If Andrew and Maisie guys want to talk about it.
So arguably, right, the reason we cared about the number of vertices was to flush the data cache, right? Or what was it? Why did we care so much about that in MP3? About knowing when we were done with the last vertex?
I think it made T last or something,
Yeah.
but we changed
Oh,
how
that right?
we
Don't
changed
go
how
T
it
last.
worked.
Okay.
Yeah, I don't know. The two at
Show
the
the
bottom.
video again, I guess, or it's really tiny.
Cool.
That's awesome.
We can full screen it, I think.
I understand switching to smaller triangles once you're doing two.
Yeah, it is small. So pretty much what it just sets the color based on a position. So like the XYZ gets sent into the RGB value
Pretty cool.
as it moves in a circle. And then these two just turn everything red. So like we specified the triangle as blue and then the shader turned it red. So I don't know. Not very exciting, I guess.
This was the test application that was supposed to use all of them, and I have everything in there, but for some reason the alpha isn't really working, only with like the colored part of the texture it is. For some reason the white is still fully white.
What texture are you applying in that application? I can't tell that.
One of the ones with the examples that had like numbers on the sides.
There's
'Cause I
like
didn't know how to apply
UV test or something like that.
That's the fragment shader. I don't know.
So that'll be the next step for the team, though, I guess. You know,
Yeah.
get basic texture mapping application working for the simplest possible, I guess, fragment shader or vertex shader, however you want to do it, and then get that hardware. See if that's required for that hardware. Your team will do that. Yeah. So, any questions for group number one? All right, way to go, guys. Now team two, come on. Report take that. Also, I asked group one final question. Where were you as of a Tuesday demo day for this?
I think Tuesday we had the depth testing working.
So an extra couple days maybe.
Yeah, and I started working the blending, but it still had like a lot of bugs. So, and I don't think we had the fragment shader.
Yeah, I was working on creating like code, so totally unnecessary.
Do I start?
Start.
Okay, so we're group two. I did alpha blending debugging, the dev software, and I also started the texture mapping software on the driver side.
I fixed some of the previous MPs, then did all the hardware texture map, and then did all the debugging for the depth test and alpha blending.
And I did alpha blending software, fragment shading software, and I helped start the texture software, and then side developed hardware.
Who's not here? So for depth testing for the software, we created lookup tables for the depth modes. There was a hardware error in where we were writing to memory. So in this diagram right here, this is our alpha blending and depth buffer on the render output. So we combine the two submodules into one, probably like how other groups did it too. But when in our hardware, when it went through and did the depth test, even if it's kind of not enabled, it would still also go through those states, and even if alpha blend wasn't enabled, it will still also go through that check state either way. But if both were enabled, they both would actually write to the cache, the memory, at the same time, which created some weird error. There was also a software error correlating with the hardware design, where this right here, this lookup where we're sending the data in, we're just sending like that one stream, just that function. But in our hardware, how we set up that buffer, our bits were different. So for all our alpha blending, we have 4 bits for the source factor, 4 bits for the destination factor, and then 1 bit enable.
And the only issue, it's not a big issue, but the only issue, so you did create a lookup
Yeah,
table,
yeah.
is, I don't think it's set anywhere in the spec when you have a GL func what the binary encoding of that needs to be.
Yeah.
It's just that there is a flag corresponding to this. So you probably need this approach, because in theory, OpenGL version gets a slight up. It's unlikely to happen, but in theory, the version of OpenGL updates, all those constants change, and then your hardware breaks. So you need this kind of virtual hardware interface to be able to keep your hardware working.
So because of how we set our bit fields for that certain register, we also made this error in the alpha blending driver code where we were sending it to 3 different places, even though we wanted to only send it to one register kind of deal. But so that's the.
Going back to that diagram. real quick. Yeah, that diagram. I mean, you could probably just skip those pipeline, or, just get out of those, or maybe you are and I missed it. Like if depth testing is not turned on, you should just skip that part of the state machine, similar for alpha. You can have both in an application. It's not necessarily that common, but you would not be doing depth testing, but you'd be setting things in the depth buffer while you're doing the alpha blending. So in theory, you can do both. But was it just bad luck that those 2 state machines would be writing at the same time, or why would that be the case that they'd be writing to?
Yeah, just some bad code design in the beginning, just some small errors here and there, but there's the alpha blending.
So alpha blending, the same thing with depth. We made a lookup table, and then all of them are hard-coded into, I think it's graphics with the encoding. And then there was that error that Long was talking about. I don't know how they fixed it. I was busy doing other things. But I assume it's the same thing where it was 4, 4, and 1. And yeah, so that was blend func with that error. And then enable that just has 2, just the blend and the depth, defaulting to blend. Not a whole lot really there. But here's some software stuff. So on the left is before I had things working. So I forgot to do 4 times the vector attribute instead of 3 times like we've been doing all semester. And so I fought with that for a week.
What do you mean?
So there's a line of code to set your color buffer, and it's 3 times.
Oh, but now you need alpha information.
Yeah, so I needed to go to 4 instead of 3, and so I didn't update that. I had the alpha buffer, I just didn't increase the size. So yeah, so I forgot to increase it from 4 to 3, so that's how I had the nice half kind of circles. And then kind of trying to figure out how each of the blend factors work, because they were kind of difficult, at least for me, to figure out at the beginning, because they just didn't make a lot of sense.
I agree, and so the other 0 and 1 are the ones that I can think about it
Yes.
and the rest are just, I mean, they're all mathematical, they all make sense, but in terms of what this color should be, 0 and 1 are the only ones that I can easily look at it and realize that the answer is correct.
There was a lot of, does this work?
Right.
Does this work?
Right.
But that's how we got that fun blending for that. And again, that's the same application we've used all semester, so the random circles.
I don't know. What is the blend going on there?
So it's like a green and a pink mixing together, which
More green?
makes kind of a teal.
Is it? Okay. It's color of the projector. and everything
Yeah,
as
it looks
well.
more like a teal. So I mean, kind of, because I mean, green and then a pink, green and red. I don't know. I assume it's right.
Yeah. Okay.
Until proven wrong, it's right.
Okay. The one thing the test is have 3 spheres or 3 circles, 1 red, 1 green,
Yep.
1 blue, and then you should have like a white intersection, right? You can see your whole
yep.
color pattern that way.
I did have it where 2 circles were the same color, and if they blended, then the circle should look like 1 giant circle. And so that was one testing. This was just easier for the demo to kind of show that blending was working. So I assume because that test works. So here's the fragment shader. So it was more driver code. So all over the place today.
Nothing new. Pretty much completely the vertex shader lines, just change it to fragment shading.
Yeah, pretty much anything we had for vertex, we put for fragment, and then we had that output, which is fragment plus vertex, or yeah.
What is the fragment shader doing in that example?
So it should be doing a clamp. I think I had it clamp from 0.5 to 0.8 on top of whatever the vertex was doing. And so it turned into this interesting gradient.
So your clamp instruction? Great. I don't know if we needed it for MP3. It was good to get it working, but
Yeah.
I didn't see any demos of it for.
Well, this is also a software example. I don't have a hardware one because we got basic functions apparently working last night.
So the pass-through, at least in hardware,
Yes.
does work. Okay.
So the texture mapping, we mainly just got the hardware done for this, but it has a separate entity, so it just sits in the shader call. So you have the text fetch command, and that'll start this texture mapping entity. So you just pass in the XY coordinates of the control signals with the mapping modes, height, width, base address, all that stuff. then it'll go through its own state machine, where it starts out just waiting for that start signal, then do the mapping modes to get the texture coordinates between 0 and 1, then convert those coordinates into the image XY, and from there it just does the memory stuff to get the actual texel and then output that. And so the hardware students we tested for this, we've done kind of like a logical step through just to make sure it logically makes sense but has actually been tested. Then the software was just at the beginning stages, so that way it just needs to get done to test this on the hardware itself.
Do you need that for your project?
Yes.
Yeah, okay. So that's good, and that seems like a reasonable approach, you know, if you're saying just 2D sampler or 2D textures, and we'll talk about this next week in class in better detail, I hope. There's the OpenGL calls to kind of associate a texture in memory, so you have to kind of, that's not in there yet, you can kind of say, here's this region of memory, here's where my textures are gonna go, have some metadata about what each texture size and base address. And then this module will just basically take that, you know, here's the base address of a texture, as well as the width, at least, you need the height and width, at least the width of the texture, and just kind of doing a 2D memory lookup, basically, like converting a 2D access into a 1D address. For now, at least, it's just doing a memory lookup. You may, for good results, need to do multiple memory lookups and do some filtering and things like that, but it depends on how much you need accurate texture mapping. And to start with, to confirm you get anything like this for everything, just make a white texture, you know, it's just all white, right? And you don't need to then open image files and things like that, just set up, or red, or whatever you want it to be, something different, and apply that. And then do a checkerboard pattern and apply that. Just start really, really basic, so that you can visually debug what you're getting back out, and start with a single triangle, right? And have the textured triangle as your first application you really need, with the most basic of textures. And because that is the right approach. You have a separate entity that the rest of the shader core is just kind of interfacing with, and the end result is just a value, right? Presumably, you know, RGBA value or RGB value that's going to then have an output of that instruction.
Also driver code for the texture.
Yeah, there's a decent amount of driver code. I mean, that module's not trivial necessarily, right? But seems like you've thought about, you know, the issues associated with it, and kind of how like clever you want the texture mapping to be. It can be quite complicated, but for just look up a texel, make that my pixel, you should be able to get it working.
So here's some fun bugs. Two of these are from when I was working with trying to figure out why blending wasn't working, and it was that whole I forgot to do 4 times instead of 3 times. I had alpha in all of these, but just forgot to do 4 times the value. So yeah, that's where this came in. And then because of that, I thought, oh, let's do part of a circle and see if that works. And there's fragment there. This is alpha plus depth, which ended up being an interesting gradient. And then this was before we had the fix and blend, right?
That was multiple bugs all in one. That Joe and I.
Yeah, there was a few issues. One was with the alpha blending. We ran to 3 different registers in software, when in reality hardware was only using 1 register and doing the different bit fields, so the upper bits for the source and destination factor were just set to 0, so that's where you get the
Just curious how that happened. I mean, that's pretty natural, but how did that, so different sides of the team working on the driver interface and then the hardware
Yeah.
interface?
I was told there were 3 registers, not told there was
Yeah.
1.
It's like we have 3 registers, but we're only using 1, so it's just kind of weird thing to have. Then the second part of this issue is if you had the depth check enabled, it would write the depth buffer values, but it would not write the color values. So even though you had something, it just won't get written.
Was there no Zach though?
No.
Okay, well, so what I'd like, particularly for this one, but for your project demo, definitely try to show and give a status update of like what works in hardware and what doesn't work. Because I still don't have a good feel for it. So tell me what works in hardware. If I had 2 intersecting triangles, does depth testing work?
So for alpha blending, the 0 and 1 work, and then depth we did like a basic test and of the orange and never, those work.
Yeah.
But we haven't checked
All,
the
like
actual.
all or never.
Yeah, yeah.
Okay. Never is pretty straightforward, I guess, right? Never was working for everybody all semester. All is also kind of MP3 in a sense, right? So it's not exactly, you don't know if it's working or not because it's exactly what MP3 would have had in place. I definitely want to see that just for the demo day aspect of, for your team specifically, you know, on the demo of the software challenges as you're working in an application are important, but not in lieu of, you know, what do we have in hardware, what is working in hardware, what do we still have to fix in hardware. And since I won't look at it today anyway, not till tomorrow, do a double check today if you can of your report, also what you submit for that, and make that part very clear as well. You know, here's what we have, here's what we don't have for MP4, so I can evaluate it without, because I do not, you may be shocked to hear, I do not take your code and like try to build a bit file with it. I look at the source, but there's only so much you can see just looking at the source, not being told what's working and what's not working. I don't know how much technical debt your team has, I guess, you know, in seeing what you have. Although the previous slide where you had, or is it the next one with like a little video?
We don't have a video.
That one, yeah.
This one.
So the fact that you have that video, that's with a fragment shader in place, just with some bugs in your render output, is that a correct statement? That triangle that is dark?
Yes.
With
There's a fragment shader in place that's passing through.
Yeah. we
Yeah.
have a shader in place.
yeah, I mean, like, it works now, but
Oh, I understand. So it is pretty far along. We just like, it's hard to tell from the presentation, you know, how far the team was, what else you have left to do. It gives potentially the wrong impression about how much you have working and how much is left. But otherwise, keep up the good work. You got one more project to get done, and then you've got it. So good work, good effort. Next team, come on.
Get out
Are you guys gonna do your respective slides probably?
Yeah.
Okay. So I had the integration and the fragment shader. I did blending.
Yeah, I did that. That's
Okay, here's our big state diagram
But
for.
the integration is like all of it though, right? I mean, so there's contributions there, but everyone has to work on integration because that's like, that includes testing, that includes debug, you know, so.
Yeah, I did a lot of the render output state machine and also the fragment shader, and then they worked on like actually understanding how those different components inside of it work, so that we could just get integrated into there. So basically, the state machine, we have our color buffer. Well, okay, so we generate our color buffer address and our depth buffer address, which is going to be like where our address is located, and then we use our depth buffer address to first read from the depth buffer and then determine if the new fragment is going to be on top or below it. And then if our blending is enabled, we go to the blending step. If not, we just go straight to like writing. If it's above, we write. If it's below, we don't write. I think we're writing to our depth buffer right after we read it, so we write to the depth buffer before we write to the color buffer. And then we kind of just like skip the depth buffer step if we have color buffer enabled and not depth buffer. And we go through both of them if they're both enabled, but that doesn't work properly right now if they're both enabled.
As I mentioned, it's kind of hard. You need a really compelling application to actually show what it
Yeah.
means to have both depth and alpha at the same time. So, because they're kind of contradictory. One is blend what's there, one is replace what's there.
They work, but it doesn't like work how I thought it was supposed to work, so.
Yeah, and depth testing, so it's pretty straightforward. We just check the incoming fragment with the depth buffer address that is already there. We check if it is less than the z value incoming fragment, and we go through some case statements in there. So, and then, yeah, we write it to the depth buffer before we write it in the color buffer. And we had some depth testing applications like the triangles. So initially we started off with a triangle all like coinciding, going straight, and we just made some modifications and
got this depth testing image.
Yeah, and then for blending, we implemented all but the constant functions. We mostly tested the SRC alpha and 1 minus SRC alpha, but I believe the other ones were working, didn't they?
They could work.
They worked as far as we could tell. Basically, yeah, we did it in these steps. Read the blending factors, we decode them, assign them, do the calculations, and write on the registers, and then move on to.
Yeah, so the tricky part is you have to read the current color buffer first, right?
Right.
Then you calculate what the two factors are based on the parameter, or you can do it in either order, I guess. And then the actual hardware for blending is the same no matter what, right? It's factor times source plus factor times destination.
Yeah, we had different blending types. Yeah.
Looks pretty good.
I like this fragment share application. It looks neat. It's not super easy to see, but it's our fragment share worked. This is an application that it chose a gray, like gradient based on the z position. So it was a bit darker in ours than it was on the.
Do you not know why? I mean, there's a reason, I would imagine.
It probably has something to do because it's using the actual like viewport value coming out of it instead of something. I don't know.
I think this is where like type conversion becomes very relevant, I think, right? So the z values that you are getting, no, because this is post viewport and you had to do the viewport, no one talked about that, but did you do the part in the viewport where there's a depth range and you do the equivalent math?
Yeah, sure.
Oh, okay, that is necessary unless, I mean, default range can be pretty far too, to be honest, but otherwise you have to set those two parameters and basically add one more state to your viewport to do depth viewport, whatever you want to call that. So you did do that.
Yep.
And
I'm not.
yours are darker, and theirs are much.
We still get a gradient though.
Yeah, you know, it looks cool. Very cool application. You're just saying color output fragment.r.b.g equals position.z or something like that.
Yeah, position.zzz.
Yeah, sure. Yeah. Come on, we can figure this out. Why would it be so much brighter in the OpenGL application?
I multiplied it by 1.5, so it would be lighter on ours, but it made it still not super light. It could be offset by a value. Because when I multiply it by 1.5, it didn't get that much lighter compared to what was on there.
You do, so that's in the fragment shader that it's doing, yeah. Color.r equals position.z, and you're doing it for all of it. Color.r equals position.z. And all those values are at that point still in that Q16.16 format. But depth is not limited to any, depth could be of any range, right? So there could be overflow, so it might be a clamping issue.
Yeah, it could be. We're not clamping depth to 0 to 1.
So it could be color values that you then clamp, whereas those are just overflowing, or just it's higher precision color values, and it's supporting a larger value range. Well, I don't know, it's fun, but I guess you don't really need to be. I mean, it's cool to see the depth information. I thought when you posted, I saw you post that picture, I thought you were like debugging the depth buffer directly. I mean, you kind of are indirectly, but I thought you were like grabbing a screenshot of the depth buffer to kind of see what was in the depth buffer, which, that application that lets you grab color buffer and just kind of save it to a file. You could tweak that and just grab any buffer you want and save it to a file. So you could grab the depth buffer and save it to a file and see what those look like. That's awesome. Okay, so what are those? A couple teams had.
Okay.
What is going on there?
Which one? The crispy one?
Yeah, what is it?
A couple teams had it? It was not just
Someone
one?
else had something crispy too.
I think for me it was because
It's not a technical term, but
I think it was because the render output was like behind a cycle or somewhere, so or behind like a fragment.
So I think what was happening was that I was computing like because I had to split up the address calculation into like two states because it was not hitting timing. So I accidentally did a thing where I used a value that is set in the same state. So I think it made things offset a little bit. I don't know if that's the issue though.
Previous values, depth, or something
Yeah.
like that, and current color.
And then the next one was fun because it was like it was me not waiting for clear completely, but you can like see the last run stuff on it too, which was annoying. And then I don't know. I think the video is the same thing. It was just a fun video.
It's
And there's
flickering,
my
right?
game.
Yeah.
Yeah.
That's pretty fun.
I love that one.
And then whatever random garbage is in DRAM and power cycle
Yeah.
being interpreted as depth is going to lead to those kind of.
You can like turn it off and then turn it back on, and it's like slightly more fuzzy.
Because DRAM kind of retains it for a little while. As your team works on anti-aliasing, right, for your project, my only, it's not a concern, but something you may want to consider, how can you modularize what you're doing in there so that the code doesn't explode? It's going to get pretty bad, I guess, right?
Yeah.
Your state machine's already pretty everyone's is, but it's already pretty complicated, and amongst the teams, your render output is going to be, more complicated than that. There's things you can do, like if you go back to your slide that had like the VHDL for reading from memory, I guess it must have been this one, where you have depth buffer, write accept, and you can actually turn those into functions in VHDL to kind of make it look, technically it's still the same thing, it's still two states in the state machine or macros, however you want to do it, so that you have this block of code that does writing at this address at this value correctly and waits for the accept and all that stuff, so that it doesn't actually change the complexity, but it changes the lines of code and the multiple places you could potentially have bugs as you're adding things to it, because I assume this is now a pretty long file for your team. I would think.
Okay. Oh yeah, Cube Flyby. It feels a little buggier than Group 1's, I think. So I'm not quite sure what's going on with Cube
Is
Flyby.
it flying?
It is flying a little bit.
The camera's moving more than your phone camera's moving more than the cube. It is.
Oh, my
And
fingers
so
in the
it
camera.
looks like it's a broken cube, so I don't think that's a bug in the application. But it is kind of cool in a sense that you're seeing like the inside of the cube almost, right? Because you're seeing like the previous triangles. And this is orthographic view and all that again.
Yeah.
You made that change, and everyone I think has made that change.
I'm not quite sure what's up with that. It's not too bad.
Right, but it's dissatisfying.
Yeah.
You say, hey, this all works, all this hardware works, but then like the triangle has like a gap in it, or it looks like it's like curved inwards, almost like someone punched a box, and like there's a little hole on that side of it. And you can see those two triangles where they join. And some of this could be artifacts of the recording. It almost looks kind of blended up there, right? Like maybe it's just it's an optical illusion at this point. Yeah.
Yeah.
Alright, well, I'm glad that the team has maintained its sanity while continuing to work on these, and we'll continue to maintain their sanity for their project as well. Do you have any other demos to show, or is that the last?
Is that it? That might be it. Yeah, that's it.
Okay, awesome.
Okay.
Oh, good job, sorry. There we go. We had time for a full round of applause. Alright, James and Will. Brandon sent me an email saying, I'm so sorry I can't make it to 488. I said, well, that's not my problem.
That's not where we're at, yeah.
Also can't make it to 488, but I understood what he meant.
That's fine.
You think 488 in 480?
No, I think you just
Just confused.
I think, yeah, they just.
added an extra 8 for funsies.
I'm first. So
You're up first. Go for it.
I'm like the simulation guy, so
By
that's
the way, a
like.
couple people are taking those classes this semester. If you love this stuff, why are you here at IC other than to learn things and push yourself, and then you're going to graduate. Life's going to be so easy after graduation.
I had to fight for my life.
Well, there's that, but push yourself when you're
Fighting
young
for
and
it.
do it, and I'm all for it. So, go ahead. Sorry.
It took me a while to ramp up because I was gone for so long. So I did a lot of like the end stuff, a lot of debugging, a lot of integration, a lot of simulation. And then I kind of just worked on like the depth test stuff. Yeah.
Yeah, Brandon and I we like to huddle around a computer. I don't know what it is about that, man, but we get work done together really well. So we kind of just sat down and powered through a lot of the MP3 stuff that we were stuck on. And yeah, we're slowly but surely clawing our way back from tech debt. But yeah,
Speaking of MP3,
yeah.
um,
This is where we were at the beginning of the week.
this guy,
2 weeks.
like the yellow and white, and also the missing, or I guess small, I don't know how to describe it. Triangles, that was an MP, is color wheel 2 or 3? MP2.
Would have been 2. That's one
It
of the
showed up in
recommendations.
MP2, and then we got color wheel working, and then in MP3 something happened, I don't know what it was. It came back when we started running color wheel. And we spent so long trying to get, like, going through simulations and looking at, like, the ILA and, like, doing all this stuff for just one day. It just randomly worked again when Brandon, or when, when Brandon rebuilt his project. Ended up being, like a Movado issue, and that was basically, like, the summary of our MP3 and 4 was, like, our files getting cached and stuff in weird ways, so we would end up running old stuff when like the file reviewing is up to date. So I think we got that figured out now. We know what to look for. There's some other cool stuff, like this guy down here. That was just color wheel, but we ran the vertex shader program. Was a shifter.
Shapeshifter, I think.
Yes, we ran shifter, and the triangle was shifted, and then the buffer wasn't, or not the buffer, the cache wasn't cleared, and so we ran color wheel. Color wheel was where the old triangle was, so it was pretty neat. The top middle one was pretty cool. We have a video of that because it moves. Then we had like weird cache issue with like a triangle appearing through like persisting through programs. And then the bottom middle was like our best attempt at getting.
It looks so close, though. I mean, well, maybe my eyes are just trying to convince me
Close-
I'm seeing something that's not
Close in
there.
the sense that that was before we even touched depth. So,
Okay.
Yeah. I think we got depth working, but that would have worked. The left is really cool.
This one's awesome.
Yeah, what is that?
It's color wheel.
It's color wheel, but the IMM.
It almost looks like there's a curve. I think
It was-
right, like that blue looks
Yeah.
like it's
It's
very hard to
it's using the instructions from Flyby, basically. I believe.
So when you are, when you're swapping shaders but not clearing the instructions, that's
exactly.
weird stuff is gonna happen.
Yeah, IMM didn't get cleared, so instead we get this really terrifying looking spinny color wheel where it's trying its hardest to be a circle.
I love it. I don't know.
Yeah, it's great. It's cool.
That would be hard to make intentionally. Like if that was the goal to replicate that program, that'd actually be fairly challenging.
Yeah, that was fun.
Most of our issues for MP4 was with like just depth buffer, like the caches, clearing set. It was all like driver stuff.
And it's kind of what I mentioned. Well, so some of that's driver stuff, but you're just having good hooks and hardware that like this block of code clears the cache, and you just have that. You wrap it into a function. It's just done. You know, you call that function. It's just going to work every time you need to clear any cache, or just document it really well. That when you need to clear the cache, make sure your code looks exactly like this.
I think that would be a good idea to start with for project.
This was just a random. I was testing something, and I had this issue where I'm not getting anything on the main screen.
Like OpenGL.
And it was like every other bit stream I ran, it just like wouldn't show up on the main screen.
Makes you wonder.
Right? Like what's happening?
But yeah, very strange.
But yeah, whatever.
Especially if it's like one of the built-in applications.
Right.
That's
It's like,
just
what
a
do you even-
shapeshifter application or some slight tweak of the
Yeah,
shapeshifter.
Yeah, we removed X basically, and the scaling. But yeah. Oh. go. Oh, yesterday. What, did I do this yesterday? I think I did this yesterday. I asked James what shapes he wanted for the diagram. And I thought he was going to say like circle or square, but he said star. So I committed to the bit.
Okay.
But yeah, basically it's the same as everybody else, I think. We have a set of states for depth tests, we have a set of states for blending, and then the original render output chunks. And it kind of just checks, at the beginning of each chunk, do you really want to do this? Are you sure? Jump to the next thing if not. And then we made an extra state for color clamping, which kind of ended up being a pain, so that we had unclamped values all the way through and then clamped it once at the end. And then we wrote it.
I think that might still be, so the question is, I'm not even entirely sure the rules on color clamping, if OpenGL even necessarily specifies those rules, and that could explain why the one application looked different. When you're doing blending, you can blend all sorts of weird things, right, that result in invalid colors in the color space you specify. So I don't think there's a correct way to do it. So clamping at the end seems as good as any approach to make sure that you see something at the end. But if it looks different than OpenGL, like the software application, that doesn't mean yours is wrong. It just means it's different.
It just means it's different.
Different than how it's doing it.
On the topic of clamping, when we had that like white and yellow, what was the app called? The color picker. Yeah, we thought that was a clamping issue, which makes sense. It's all white and like there's some part of yellow, and that just was like a massive red herring, which was so much wasted time doing that. But
We had we would.
I was going bit for bit,
Yeah.
like handwritten out with the simulation is.
Talking with
Yeah.
a former colleague who works in the industry and does a lot of Vivado stuff and has a large team that does it, and I asked him, how does your team deal with all the idiosyncrasies of Vivado, right?
Mm-hmm.
Just all the ways you can just have problems like that where you're running old code. And they basically use Vivado without ever opening the GUI at all. So it's all entirely, so they have like just scripts upon scripts upon scripts. And so they're still required to use Vivado to build anything. But it's just kind of a binary blob compiler that they never look at ever. And everything else is just automating all those processes. Because I think if you get the right script to do exactly what you need to do, it does work. It's just a matter of the GUI sometimes hiding that this IP core wasn't updated, or this gets locked, or this file gets confused. So that might be, that's a lot of work, I think, to set that up. And there's people whose job is only to get in charge of
optimize
the test infrastructure for the whole rest of the team. It seems like the way to do it, that you're not actually using the GUI, dealing with the headaches that it can cause.
Yeah, we just kind of got good at nuking our project files and rebuilding them.
For depth testing, that did not exist as of a day and a half ago. So this
Oh
is,
yeah, the extension was
This is
outstanding.
doing of the much needed few days, but I basically just kind of crammed this out. What is that on the left? Oh, that's where we actually calculate the factors. So these, I just closed the case statements, but that's the big long list of, hey, which one are you doing? And then below it is the actual like multiplication and addition. How does it go? Where am I?
That's blending on the left,
There's a
and
little bit of blending.
depth is on the right.
Oh,
Yeah, that's okay.
okay, yeah, I definitely, okay. Yeah, and this is just a big switch case statement for the different
So you only go into that whole state machine when depth testing is enabled in the first place, like your statement
Yeah.
you're showing. It doesn't quite show it for blending, but it's the same thing, right? If there's no blending turned on, you skip that whole set of red stars.
Yeah, we just have like
Correct.
two statements.
Yep, there's both a check at the beginning at the wait for fragment state,
And
and
at the end of it. Got it.
yeah, so
Got
that I think the it's ordered so that depth comes first.
We do all of our like color calculation from like 0 to 1 to like 0 to 255. That's all done like outside the process. So we didn't need like an intermediate state before blending
Mhm.
because we do all the getting our stuff in the ends.
Oh, I thought it was funny. It's going back to blending. Brandon tried to do all of the blending factors outside of the process, and it was a hot mess. And then yesterday, did we do that yesterday? I don't remember
I
what
wasn't
day.
paying attention to what you're saying.
That's okay. You don't have to pay attention. I'm rambling. Anyways, we like commented out all of his hard work and changed it to case statements, and now it looks pretty.
Also, the theme with our MP4 is that I've simulated everything as best as I can with a bunch of TCL scripts. But us having like these buffer and cache problems, it's just kind of hard for us to like run that. Like we can't run depth right now, like at all, basically. Like we can run like the square, but it's like broken. But we can kind of get alpha blending. I kind of worked on it at the very end. Brandon and Will like started it off. And by the end of it, the simulation looked great. All the colors were coming out correctly when I input like the source and destination. So it must be like either like grabbing the values from the actual depth or not depth,
DMAM?
the color buffer.
Color
Yeah.
buffer.
Or maybe it's like a switching the color buffer or something like that. But you can see that on the left is like the normal, and then the right is ours, and ours is just like not blending it. And I don't know the actual value of those, but I'm assuming it's just what the color is for source.
It could still be that like something with how you're configuring your state machine, like does the driver send the right configuration register value so that it's actually doing the blending state machine. So one thing to always add would be some way to inspect either via software or via ILA. Wet state lane is always pretty important for this. Like the ones you had to find that button Fmul to where am I? Am I ever actually in the alpha state machine would be good to know.
Is there a way to do that outside of the ILA?
Well, there is. I mean, you could always just say, hey, for this create a new register, maybe make it separate, and have a very simple data flow log. It says when I'm in this state, this register has this value. When I'm in this state, this register. Just encode the state machine and set it to that register. But you can also just click on the signal and add it to your ILA and just get that inspection of every time that value changes. Does it ever change such that it's in the state you think it would be in?
I think the ILA is what we're going to need for a lot of this. This type of testing we need to fix these, like the alpha blending and the depth. And we also have an issue that's also cache related, where whenever we run the program initially, it works fine, like our fragment shader and our vertex shader. But if we run a subsequent program that has a different fragment shader, it'll like just
Be a gray screen.
die. It'll take the clear color on the screen, but it won't draw anything, won't render anything.
So definitely, I mean, there's definitely some cache. You talk about both instruction and data caches at different times need to be invalidated. But for depth, that would be an issue, right? If you're not flushing your depth information, then who knows what you're actually reading in. But for alpha,
I think
there's something there, right? That you're grabbing. Assuming you're getting to that part of the state machine, you're grabbing something from the color buffer.
I was trying to like decipher it from, I used source alpha at 1 minus source alpha, and then I used like some other ones. Like 0 and 1.
I would add those values to register too. I mean, that ILA is fine too, but software accessible registers are also really nice that your driver can just constantly monitor and print out that information. Are you getting alpha values that are not 0 or something like that all along the way? And that could be one reason. But
Yeah. As far as I know, and please correct me, it sounds like mathematically everything should work, right? The blending should work, the
if
depth
we get
should
the
work,
right values in, then
but it's just not grabbing anything from caches. And we pretty much covered all of this already. Our complaints,
Yeah.
our sadness.
Oh, Movado started crashing on me, like at towards the end.
Anybody else?
Like a lot more crashing.
I recall that from last spring. That for no reason other than the project became more complicated. It just starts to crash.
Yeah. Once I started simulating these past few days, it just I feel like it'd be like once every like third try. Not a huge deal because I was just simulating. I wasn't like doing midstream, but mildly annoying.
Oh, your OpenGL program.
Oh yeah, so I wrote like a really basic OpenGL program, but the way I was writing it was I had my data array, like my vertex array, and in that data array, I would have like my 3 vertices, and then I would assign my 3 color attributes right after it, and the problem is that our GPU just like has a hard limit on like the attributes.
That's just driver though. I mean,
Yeah.
we could support that and have it split them up and put them in the appropriate locations. But
So
it's probably not worth it. I guess, you know.
The output was like messing with me when I could have just looked at the console and it said, "Hey," it was giving me a warning for it.
Was the
And I thought it was
strides
a
too
bug.
long or something?
Yeah. Oh, I put
It
some
supports
examples.
just the stride of one, right? It doesn't support any other
Yeah.
stride. But that's fixable. It's just probably not. It's a lot easier to fix your application
yeah.
than change your application.
I put in examples of quite easily avoidable bugs. This one was kind of annoying. 'Cause I didn't just see it initially. We're in GL enable, and we're enabling it, but then we sleep and then disable it.
Because that was like
We copied it from like our clear buffer,
yeah.
and we just didn't delete those lines. So that was the headache. But I saw it immediately when I looked at it. It was just we never like went back to that function. And then this one, if you can tell, we're writing the destination factor to the source, and so our destination would just be like all zeros or like garbage, and that was causing some weird bugs. But
Great, you really look at the code and find that.
yeah.
And maybe, you know, having to step away from it also helps. Like you look at it, it's all new to you, and you know, at the time you get a fresh perspective on code people have been placed all over.
Cool.
Just some like key takeaways from it is that we know what we need to work on. I don't think we're like lost in the weeds on like where we need to start.
All right. We at least know what's wrong now, which feels good.
Yeah.
Feels a lot better than being blind. So, yeah.
That's good. And you gave yourself credit for fixing the remaining stuff for your project anyway. So it's not wasted effort. I mean, it's necessary effort, and you get credit for doing it. And I think that's a perfectly valid approach to take. Remind me, your team's project is which one again?
Just fong lighting, or I forgot how to pronounce it.
Yeah,
Yeah,
the lighting model, and there the question is how much we already looked at that.
Right.
How much assembly stuff you have to do. The nice thing about that though is that that's pretty orthogonal to all of this like hardware debugging stuff, right?
Yeah.
And you do need to make sure like the MVP transform works. Ultimately, like, you can do matrix vector stuff to get that to work. But then the person who's looking into, okay, we need to support these instructions or maybe some other aspects of the speeder V output, kind of work on that on the side. It doesn't break what anyone else is working on.
I feel like we could each individually kind of pick at something.
Yeah. Where some of us focuses on, here's the 5 critical instructions that I know will require extra hardware in my shader core. That can also be kind of independent of the rest. So there is kind of 3 like major tasks that you can split up. Any questions for our fun for today? All right, good work.
Thanks.
You took a long time talking, so.
No, that's good.
You gave us 12 minutes. So.
I gave you 12 minutes this time, and if you needed 15, that would be fine. And for our very final demo date, which I believe is Tuesday during exam week, but I always have to look it up. You have to look up the website and kind of reverse engineer when your own exams are. We will be in here during that time. It's roughly at the same time. Maybe it starts at 9:15, but it's roughly at the same time. And you basically, given we have 4 teams, you have as much time as you need to give a presentation. But for that one, do try to structure it I thought these were fun, but do try to structure so you're giving a nice logical walkthrough. We'll talk about that when we get a little bit closer to it. It is still just a demo day presentation, but you have more time. You hopefully have a little bit of time to like prepare as a group how you want to be able to do your demo presentation, and I think those will go really well. Otherwise, don't forget about your projects. As the weekend comes, we go into next week. Progress has to start today. Just look at the calendar and look what we have remaining. Is it May? It's early May when we're having our final demo day, that Tuesday. So it's coming before you know it. Roughly of the complexity of a given MP assignment, but it's without any document, right? You're kind of on your own. You're deciding as a team what you need to work on. You're splitting up the tasks. They are all very doable. We don't know the exact issues that have to be resolved to solve the particular challenges you will encounter. But working on technical depth is definitely a good way to get started. It can't be the only thing you do, but it's a really good way to get started for that project. Let's leave things here for today, and we'll talk about texture mapping in more depth on Tuesday, and that'll help a few teams, I think.